Welcome to True Projects. In this video, we are going to explain about the project, which is energy efficient task offloading and resource allocation for delay constrained edge cloud computing networks. So before getting into the execution, first let's understand what is the project about. Take real-time gaming for example, where players expect instant responses on their actions, and even a small delay can ruin the experience. Similarly, applications like augmented reality require quick data processing to blend virtual elements seamlessly with the real world, while autonomous vehicles rely on rapid decision making to ensure safety on the road. So these type of applications need extremely low latency responses, fast communication network, and high computation power. Traditional cloud servers. So these traditional cloud servers, although they are powerful, they can't always meet these demands because they often located far from the users, causing delays. This gap between the need for quick responses and the limitations of the centralized cloud computing has driven the rise of new solutions like edge cloud computing. Edge computing. So let me explain you again. Traditional cloud servers, they provide plenty of processing power, but since cloud servers they are often located far from the users, the response time can be high. This delay becomes a problem for applications that need real-time responses like gaming or autonomous vehicles. So to solve this, edge computing brings server closer to the users, reducing latency. But the problem is these edge servers have limited resources compared to the cloud servers, which means they can't handle too many heavy tasks on their own. That's where a collaborative edge cloud approach becomes important. So, in this situation, collaborative edge cloud computing becomes important where tasks are distributed between both the edge and cloud servers to maintain the required performance. But managing this offloading process is challenging because multiple devices compete for limited resource at the edge, and high transmission latency still affects cloud performance. On top of that, energy consumption becomes a concern as mobile devices need to save the battery while using these networks efficiently. So, to tackle all these issues, in this project, we focus on developing a cooperative edge cloud computing network that makes task management more efficient. So, here we introduce partial task offloading, which means tasks can be split and processed across both edge and cloud servers, depending on what each task requires of the available resources. So, this dynamic approach ensures that the tasks are assigned in the real time to the most suitable server, whether it is closer at the edge or more powerful in the cloud. So, to efficiently handle this process, the system uses binary tree based task offloading, which is BTTO. So, here we have used BTTO algorithm, which helps in smartly distributing tasks. The goal is to serve as many mobile devices as possible while keeping the energy consumption low. Additionally, the project adapts to changing network conditions and resource demands, ensuring smooth performance even when workload fluctuates. So, as an extension, in this project, we have introduced data transmission efficiency and security during task offloading by introducing a data compression algorithm. So, here we have used data compression algorithm for data transmission efficiency, and we have used SHA-256 for security. So this reduces transfer size, data compression algorithm. It reduces the size of the transferred task, leading to faster transmission and lower energy consumption. Additionally, SHA-256 hash verification mechanism to ensure data security. So by using SHA-256 hash code verification mechanism, data integrity will be ensured. So, this security measure safeguards mobile devices by verifying that responses from cloud servers have not been tampered with or altered by attackers, ensuring both efficient and secure task offloading. So, this is all about the theoretical concept of the project. So, to implement this project, we need some basic software and hardware requirements. So, coming to software requirements, we need Python ideally of 3.7.0 version, and hardware requirements are processor of i5 and above, RAM of 8 GB and above, ROM of 20 GB and above, operating system of Windows. Now let's execute the project. To execute, we need to open the code folder which contains source code files. So open the code folder. So here we have two source code files. One is Python code file in which we have project related code in that, and this is the run.bat file. Instead of executing the project through command line interface, we have created this run.bat file. Now we have to double click on this run.bat file to execute the project. So here the Python file has been compiled, and this is the front end of the project, that is the graphical user interface of the project, which is developed using Tkinter framework. Now let's start executing the project. So first we have to we have to input the devices that we want to generate. So let's generate 30 mobile devices. Now we need to click on generate edge network so that a visual representation of the edge network will be created. So click on that. Here, all the red color circles represent mobile devices and the blue color circles represent, we have three blue color circles which represent mobile edge servers. So here we have three mobile edge servers and 30 mobile devices. And for each circle, for each mobile devices, label has been given. Now let's initialize BTTO algorithm, which will randomize the offloading cost and energy levels for each mobile node. So click on initialize BTTO algorithm. It has been initialized, which will randomize the offloading cost and energy levels for each mobile node. Now we have to click on this run existing task offload button to allocate offload requests to available edge servers with considering the cost and energy. So click on that. So here if we observe, output shows that offloading process with the black lines indicating task being offloaded to the nearest edge servers. So now let's click on proposed offload simulation. So click on that, run proposed offload simulation. And here also, offloading process is being done with the proposed model, including the hash code with the verification for each request. So here we have verification hash code. Now let's offload the task again. So click on initialize BTTO algorithm. And now let's run using existing task load. So it has task is being offloaded. Now let's offload using proposed method. So click on that. Task is being offloaded to the nearest mobile edge server. And now a verification hash code has been generated. Now let's initialize BTTO algorithm and again offload the task. So click on that. Run existing task offload. To the nearest mobile edge server, task is being offloaded from the mobile devices. And now let's run using proposed model. So here also, to the nearest mobile edge server, task is being offloaded. Now let's check the comparison graph. So let's click on served MD graph. So this graph, by using this graph, we can compare the number of mobile devices served by the existing technique versus the proposed technique. So here on the x-axis, we have the number of experiments, and on y-axis, we have number of served mobile devices. As we have done three simulations, that means three experiments, we have 3 points coordinating. So here, blue color represents the proposed technique and green color represents the existing technique. If you observe both the techniques, proposed technique is serving more mobile devices than the existing technique. Now let's click on energy consumption graph. So close this graph, click on that. So by looking at this graph, we can compare the energy consumption between the existing and the proposed. So here on x-axis, we have number of experiments and on y-axis, we have energy consumption. As we have done three experiments, we have three coordinate points. So among both the techniques, we can observe that proposed technique is taking the less energy than the existing technique. Now let's check with the extension. So click on extension energy graph. So this is the extension energy graph. With this, we can compare energy consumption between the proposed data transfer and the extension's compressed data transfer. So we have mentioned that extension, for the extension, we have used some data compression techniques to transfer the data so that it will take the less energy. So here on the x-axis, we have number of experiments and on y-axis, we have compressed and normal energy consumption. So among both the graphs, among both the techniques, extension is taking the less energy. It is consuming the less energy to transfer the data than the proposed. Now let's close it. So this is how to execute the project. So this project helps users to efficiently manage task offloading in edge cloud computing networks by using the BTTO algorithm. So users they can serve mobile devices while reducing energy consumption. The added data compression and SHA-256 verification ensures that secure and quick data transfer. So this makes it a useful tool for applications. It can be implemented with the further improvisations in real-time gaming and augmented reality where speed and efficiency are crucial. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.